Nomenclature. Nomenclature. It's very fun. So we should learn nomenclature. Yeah.
All right, let's talk about nomenclature in organic chemistry. Now, nomenclature is really interesting in organic chemistry because, as you remember, organic is a little different than Chem 1 and Chem 2 or general chemistry. In general chemistry, we just name everything by the elements because everything has different elements or the elements have different charges. Whereas organic chemistry is essentially a bunch of functional groups held in certain places by the shape of the molecule. And just like my hands can hold this pencil, and my mouth is here, and I could grab food and eat the food, right? And my mouth and my hand, which are the functional groups, are held in their positions by the skeleton, which is my skeleton, which is the carbon backbone in organic chemistry, right? So we have functional groups held where they need to be held to do different things by the skeleton or the carbon backbone. Well, let's take a look at how we then name these things because they all have carbons and very similar functional groups. So the way we name them is pretty interesting, and it starts with a base or a root, which is the longest carbon chain. So let me draw one for you and we'll talk about how this works. So looking at this simple hydrocarbon, meaning that it's only a carbon chain with hydrogens attached, and the hydrogens are completely filling all the spaces, which we call saturated. It's saturated with hydrogens. We can go ahead and number this carbon chain. So let's do that. Now we remember that when we number carbon chains, that's where we get the name from, as I mentioned. And we have a special way of counting carbons in organic chemistry. So if you recall or look at your text or notes, it's meth, eth, prop, bute, pent, hex, hept, oct, non, and then dec. So this one is 8, so this would be oct. And it's a hydrocarbon, meaning it only just has hydrogen. So this is a simple octane. Now, we right away see that they are numbered. I've numbered these carbons. That's because in organic chemistry, we always have more complex situations than just an octane. What we have is, let's say we were to take this hydrogen off right here and put another carbon here. Now, what is that called? Notice we took off a hydrogen, right? We got rid of this hydrogen. We substituted the hydrogen. We substituted the hydrogen. We call this a substituent. Substituent, because it's where we substitute something. So we get rid of this hydrogen and we replace it with a carbon that actually has 3 hydrogens on it like this. So a meth, remember 1 carbon, so it's a meth. We've substituted that there. So we call that a substituent. Now note this substituent, or this meth, because it's a substituent instead of the base, we call it a methyl. That YL ending is for a substituent. So how do we say, if we say methyl octane, this is really useful, right? Because now we know, hey, this has a side branch that is 1 carbon. The question is, where is it? How do you know where that methyl is? Well, you probably already see that I left these numbers for a reason. Those numbers are going to tell us where it is. So in this case, it is at the 3 position, so we have 3 methyl octane. Now you may have noticed something interesting. If we have octane or 8 carbons here, couldn't we have numbered them in the blue direction, meaning instead of a 3, this would be a 6. Sure. Now the rule that we have to have, because we always have to have a name refer to only one molecule, is that we pick the lowest number possible, and that's how we know it is the 3. Now let's go through how we pick those rules in some more complex situations. What if we had another substituent and that substituent was over here? And what if this substituent was a little more complicated? Look, it's got 2 carbons here. Now this is an interesting situation because if we ever add carbons like this, we need to pay attention. Is the longest carbon chain still 8? Well, look, if we have 6, 7, 8 there, we have 6, 7, 8 here. Sure, it doesn't matter. Both directions, we have the same number of carbons. So now let's take a look at what we've done here. We could number this if we go 1, 2, 3, 4, 5, 6, or we could number in the opposite direction 1, 2, 3, 4, 5, 6. So we have 2 options. We could go 3-methyl, and then we would go 6, and this would be an ethyl. How do you know ethyl? Because it is 2 carbons long, as we noticed that substituent. So we could have 3-methyl 6-ethyl octane. Or, if we wanted to go in the blue direction, we could have 6-methyl 3-ethyl. Now, these are the same. We could have 3-6 or 6-3. Now let me show you one more important rule here. Whenever naming something, we must alphabetize the substituents. So what we have here is E before M. So what does this mean? We have to switch these up. So which one now is it? Well, now we've alphabetized them properly. And I'll tell you the rule. If the numbers are tied, then you would pick the numbering system or numbering direction where the lowest number would come first. And remember, the order is determined by alphabetical substituents. So in this case, we would actually pick the blue numbering system because that would go 3 and then 6. Now, let's look at one more example to make things a little more complicated. Well, what if instead of just having 1 methyl here, what if we had 2 methyls here on this one? What if there's another methyl now here? So now we have this situation. Well, that means instead of just methyl, it's going to be 6,6-dimethyl. Now, this is a 6, and it says dimethyl. Why? Di is the prefix that we put on something to say there's 2 of them, right? Because there are 2 methyls. 1, 2, so that's dimethyl. Now that means there's 2 6s. Well, in this case, we could number in the opposite direction as you notice, and that would give us 3,3-dimethyl, and this would be 6. So we'd have 6-ethyl 3,3-dimethyl. Well, our options here, if we just look at the numbers by themselves, are 6, 3, 3, or 3, 6, 6. Now in this case, what we would do is we would pick the one that has the lowest of the second number. So let's change the order. Let's look here. We have a 3 and we have a 3, so those are the same. Okay, next number. We have a 6 and a 3. Obviously here the 3 is lower, so we'd go with the red one, the red direction, because it has 2 3s instead of just 1. So whenever the first number for lowest number ties, we go to the next number. So the order of things to look at, you want to pick the number that has the very lowest number overall. Just one, look at whatever substituent have the lowest number and number in that direction. If they are tied, the next rule we go to is this one. You look at the second number, then the third number. If all the numbers are tied in either direction, you pick the one, remember we alphabetize these, you pick the one that would have the lowest number first, i.e. the lowest number on the best alphabetized one. Now, one last point here. You might say, hey, wait, we have dimethyl now, don't we? So isn't wouldn't D go here before E? Well, we do not alphabetize by prefixes like di, tri, tetra. You only alphabetize by the base of the substituent, which is methyl, ethyl, etc. So that is how the basics of how we number these. There can be many more complex situations. Now, we need to go from just numbering the root chain into what happens if there is an actual functional group here. So let's do that next. Here we have a 5-carbon chain. This 5-carbon chain, as you're already used to naming, right away you're going to say, hey, this is obviously pentane. So what if we have a functional group here? Well, let's go ahead and put a functional group on, and let's also do some other interesting thing. So if we went ahead and put a substituent here, so let's say we replace that hydrogen with a methyl, and then let's say on top of that, we also were to put an alcohol on this, and let's say that alcohol is right here. So if we look at this situation, how would we name this? Well, an alcohol is OH, as we know, and that functional group adds an ending of all, or OL, to something. So that would mean, very simply, this functional group or substituent that is a functional group here would change the suffix here to all. Now we also have this substituent right here that I'll go ahead and put in red, because this is a substituent that is a prefix. This is a methyl right here. So how are we going to name this? Well, we have two ways of numbering it. We have this way, or we have... Well, this is a pretty simple name. Like I said, we're going to have an all ending because it's an alcohol. And then before that, we're going to have our methyl group. So let's go ahead and try to name this, all right? So this is an pentol, and we have to first of all put the number that refers to where that that alcohol is. So this is going to be a 2-pentol, and where is the methyl? It's right there on the 3rd carbon. So we're going to go ahead and say 3-methyl. This is a 3-methyl pentol because the methyl's at position 3, alcohol's at position 2, so we have 3-methyl 2-pentol. All right? Another way that this is named, and the more recent naming convention, is actually putting the number also over here, so it can be pent-2-ol. And this would move 3-methyl here, so it could be 3-methyl pent-2-ol. This is a commonly seen convention in recent days. The other thing that can happen is sometimes you could have 2 alcohols. So what if there are 2? What if we had one here, an OH, and what if we had an OH here? So we have 2 alcohols. Well, that would mean it's a diol, just like the other prefixes. We can add di to refer to 2. So this would be diol. So this is a 3-methyl pent-2-diol. So that's how we name alcohols as a functional group. There are other functional groups we can look at in the future that can be named differently. But just remember the numbering convention we have to look at one more time. What if we had the methyl somewhere else? What if our methyl instead was at the very... What if our alcohol was here and our methyl was here? Now how would we name this? Well, now we need to remember one last numbering rule. And our last numbering rule is that you always want the lowest number, if all else fails, you always want the lowest number for your base functional group. So this is an alcohol, so like we said, this is a pentol. So we would want to choose the blue numbering direction, in this case, because that would give our alcohol the lowest number, and then the next lowest number would be for our side chain here. And so this would be 4-methyl pent-1-ol, or 4-methyl 1-pentanol is another way that it can be written. Remember, we can put that number in either place for the number that's referring to the functional group that is on the base chain. So there we go. Now, important thing to note, there are other interesting exceptions, rules, and things that you just need to practice, and your textbook does have a lot of practice and more information on this. But the basic idea of how we name something is look for the functional group, and look for the longest carbon chain that the functional group is attached to. We then number the longest carbon chain, look in both directions of numbering, and decide based on our rules which direction we're going to number them. The direction that we're going to number them would give priority to the lowest number in the order of these things: the functional group, then the lowest number possible for a substituent, then if those tie, the lowest number for the next substituent, next, etc. And then lastly, the one that would put the lowest number in the first thing listed. And that would be our order of preference as things tie and we need to break a tie. So that's how we select the number, and then you list the things out that are attached, starting with any side chain first, and then we would end with the base chain, which is the longest carbon chain, and then the functional group attached to it. Not forgetting numbers associated with each of these things. Now, like I said, there are rules for when you can leave off numbers. There's also, what if we have more than one functional group? Well, there are a lot more rules we're going to learn about nomenclature, but this is the basic idea of how you name things.